Hello everyone, welcome to my channel. I am Rushali Gujar. I will be guiding you through today's topic answers of some short questions of linear algebra. So my first question is find rank of the matrix A. So matrix A is given, we have to find the rank of that matrix A. So how to find rank of that matrix A? For that we have to convert given matrix into row echelon form using row operations. After that, the number of non-zero rows in that row echelon form gives the rank of A. So the first step, we have to convert this matrix A into row echelon form by using row operations. So what is row echelon form? For that we have to convert this to first element A11 as 1 and then A21, A2, A31 as 0. So 1 here, 0, 0 here. So for making to 1 here, we divide this row by 2. So A is this one, 2, 2, minus 1, 3, 3, 4, 5 minus 1, 5, 6, 4, 2. Divide first row by 2, we get 1, 1, minus 1 by 2, 3 by 2. Second and third row as it is. So now we have to convert this 3 and 5 into 0. So to make 0 here, we use operation R2 minus 3R1. And to make 0 here, we write the operation R3 minus 5R1. So R2 minus 3R1 and second operation will be R3 minus 5R1. So first row as it is. Second row becomes, after doing this operation, row operation R2 minus 3R1, we get second row 0, 1, then 5 plus 3 by 2 is 13 by 2, and minus 1 minus 9 by 2 is minus 11 by 2. Minus 11 by 2. And after doing this operation R3 minus 5R1, we get 0 here. Then 6 minus 5 is 1. 4 plus 5 by 2 is 13 by 2. And again 2 minus 15 by 2 is minus 11 by 2. So after doing these two operations, we get this matrix, but this is not row echelon form. We have 1 here, 0, 0 here. We have 1 here. We have to make 0 here. So by using the row operations R3 minus R2, we get so R3 minus R2, 0 minus 0, 0, 1 minus 1, 0. Again 0 here and 0 here. So 0, 0. So this is the row reduced echelon form. 1 here, 0, 0 here, 1 here, 0 here, and 0 here. So number of non-zero rows in this row echelon form is 1 and 2. So rank of A equal to 2. So rank of A is denoted by this notation. And here for this matrix A, we have rank equal to 2. Now this is second matrix A. We have to find rank of A. So we have to convert this into row echelon form, and the number of non-zero rows in that row echelon form is the rank. So for this, we are going to make 1 here. So we can interchange first row and second row so that we have 1 here. So first operation is R1 interchange with R2. We get this R1. So given matrix is A, and we interchange R1, R2. Okay, so this is 1. We have to make 0, 0 and 0 here. We can clearly say that this R4 is a multiple of R3. That is, R4 is equal to 2 times R3. So we can take 2 common in R4 so that we get, or we can divide R4 by 2, we get R4 as, which is same as R3. So we can use the operation R3 minus R4 minus R3 so that we get 0 row here. So use this operation, or R4 minus R3, we get 1 minus 1 minus 2 minus 4, all 3 rows as it is. Minus 1 minus 1, 3, 2, minus 3 minus 5, 0, 0, 0 and 0 here. Now make this 0 and 0, make 0 and 0 here by using the row operations. R2, here we have 2, so R2 minus 2 R1, and here is 3, therefore we make R3 minus 3 R1. So we are going to use the row operation R2 minus 2 R1 and R3 minus 3 R1. First row as it is, second row 0 here, 0 and 0 here. Second row will be R2 minus 2 R1, that is 3 plus 2 is 5, then 3 and 7 here. Again R3 minus 3 R1, 3 minus 3 0, 2 minus minus plus 3 is 5 again, minus 3 plus 6 is 3, and minus 5 plus 12 is 7. R4 is this one. So we can see that R3 and R2 are same rows, so we can use the row operation R3 minus R2, so that we get 1 minus 1 minus 2 minus 4. First row as it is, second row as it is. Third row will be the 0, and fourth row it's also 0. Now this is row reduced echelon form. We can see the number of non-zero rows are 1 and 2, so rank of A is equal to 2 here again. So in this question, it is given that this system of linear equation is consistent. We have to find the value of k. So for that, we convert this system in matrix form. Ax is equal to b. So, and we have to write the augmented matrix AB, which is given by A by B 2 1 4k, next 4 1 10 and k square. It is given that this system is consistent. System is consistent, that means given that rank of A is equal to rank of AB. This is given. So for that we have to find rank of A. So for finding rank of A, we have to convert this into echelon form. Again, we have to make 0 and 0 here. So what will be the row operation? So row operation will be R2 minus 2 R1 and R3 minus 4 R1. So first row as it is. Second row will be 0, minus 1, 2 and k minus 2. Third row will be 0, minus 3, 6 and k square minus 4. Again we have to make 0 here. So we are going to use the operation R3 minus 3 times R2. First row as it is, second row as it is, third row will be 0, 0 and 0, and here we have, and this element will be the k square minus 4 minus 3 times k minus 2, that is 1 1 1 1, 0 minus 1 2 k minus 2, 0 0 0, and here we have k square minus 3k plus 2. So after simplifying this, we have k square minus 3k plus 2 equal to 0. So this system is consistent, that means rank of A is equal to rank of AB. Here we have clearly say that number of non-zero rows for A, this matrix A, is 2, 1 and 2. So rank of AB should be 2. Rank of A is equal to 2. That means rank of A and augmented matrix AB should be 2. That means k square minus 3k plus 2 is equal to 0. That means k minus 2 and k minus 1 equal to 0. That means k is equal to 2 or k is equal to 1. So these are the values of k, so that this system is consistent. Next question is, A is given by using Cayley-Hamilton theorem. We have to find the expression of A cube. So what is Cayley-Hamilton theorem? Cayley-Hamilton theorem states that every square matrix satisfies its characteristic polynomial. So for that we have to find the characteristic equation of this matrix A. So for 2 by 2 matrix A, the characteristic polynomial is lambda square minus trace of A into lambda plus determinant of A is equal to 0. So what is trace? Trace is sum of the diagonal values. So diagonal elements are 1 and 3. Sum of this diagonal elements is 1 plus 3, that is 4, and determinant of A is equal to 3 multiplication of 1 and 3. 3 minus 4 into 2 is 8, that is minus 5. So characteristic polynomial is lambda square minus 4 lambda minus 5 is equal to 0. So by Cayley-Hamilton theorem, every square matrix satisfies its characteristic equation. That means we replace lambda by A in this expression. So what we have? We have A square minus 4A minus 5y is equal to 0. We want expression for A cube. This is in A square. We multiply this equation by A, we get A cube minus 4A square minus 5A is equal to 0, and A cube is equal to 4A square plus 5A. So this is the required expression for A cube. We are not going to find value of A cube here. So this is the only expression for A cube. So next question is, matrix A is given. We have to find eigenvalues of A inverse. So for that, before that we have to find the eigenvalues of A matrix. So clearly this A is lower triangular matrix. A is lower triangular matrix. Triangular matrix. And therefore the eigenvalues of A are nothing but the elements of main principal diagonal. So for upper triangular matrix or lower triangular matrix, eigenvalues of that matrix are nothing but the elements on the main diagonal, that is 1, 2, 3 at the main principal diagonal elements are there. Therefore eigenvalues of A is are nothing but 1, 2 and 3. So eigenvalues of A are 1, 2 and 3. We are going to find eigenvalues of A inverse. So how to find eigenvalues of A inverse? Again by a property. If lambda is eigenvalue of A and A is non-singular, that is determinant of A is not equal to 0, then 1 by lambda 1 by lambda is eigenvalue of A inverse. So by that property, as 0 is not eigenvalue, so determinant of A is not 0 here, it is non-zero. Therefore eigenvalues of A inverse are nothing but 1, 1 by 2 and 1 by 3. So 1, 2, 3 are the eigenvalues of A, and eigenvalues of A inverse are 1, 1 by 2 and 1 by 3. So next question is, what is the condition for inconsistent system in terms of rank? So given system Ax is equal to B, where B is not equal to 0. So non-homogeneous system Ax is equal to 0 is inconsistent if and only if rank of A is not equal to rank of augmented matrix AB. So condition for inconsistent system is rank of A is not equal to rank of AB. Next question is, what are the eigenvalues of symmetric matrix? So there is a property, the eigenvalue of symmetric matrix are always real numbers. So eigenvalues of symmetric matrix are always real numbers. Next question is, if A is equal to this matrix, we have to find trace of A. Trace is nothing but sum of the diagonal element 1, 2, 3 are the diagonal element. Therefore trace of this matrix is 3 plus 3 is 6. Now next question is, we have to examine the linear dependence and independence for these vectors x1, x2, x3. So clearly we can see that x3 is equal to 3 times x1. If in the given set of vectors x1, x2, x3, any two vectors or any three vectors are if there is relation between any two vectors, then that vectors are called as linearly dependent. So there is a relation between x3 and x1, or we can say that x3 is equal to x1 plus x2. So there are relation between the vectors. If there exists relation between any vectors, then that vectors are linearly dependent. So these three vectors are linearly dependent vectors. Next question. So this is homogeneous system of linear equation. Because b is equal to 0 here, we have to examine the system is consistent or not. So clearly we say that we have Ax is equal to 0, and where A is equal to this matrix 3, 2, 1, 1, 4, 1, 2, 1, 4. So for homogeneous system, if we have matrix A, square matrix A, and if determinant of A is not equal to 0, then system has unique trivial solution. The question is, we have to examine the system is consistent or not consistent or inconsistent. This is homogeneous system. Homogeneous system is always consistent. So answer of this question is this system is consistent. They are not asking the system has unique solution or infinite solution. They are asking to examine the system. So this is homogeneous and which is always consistent. If they are asking the solution of that system, then we have to use this property. If determinant of a is not equal to 0, then system has non-trivial unique trivial solution. Here determinant of a, you can find the determinant of a, and determinant of a is not equal to 0. Here it has trivial solution, that means x is equal to 0, y equal to 0, and z is equal to 0, which is unique solution. Next question, we have to examine the vectors as linearly dependent or not. Again, there is relation between x2 and x3, that is x2 is 2 times x1. There is this relation, that means x1 and x2 are linearly dependent. Are linearly dependent. Linearly dependent. Next question is, what is trace in terms of eigenvalues of matrix? So trace for matrix A is nothing but sum of the eigenvalues. It is sum of the eigenvalues. What is determinant of A? So determinant of A in terms of eigenvalues is, it is product of eigenvalues. Product of all eigenvalues. Next question is, given matrix A is this one, and we have to find the eigenvalues of matrix A. So for 2 by 2 matrix, the characteristic polynomial, we have to find eigenvalues, that is characteristic values by using characteristic equation. So for 2 by 2 matrix, characteristic equation is lambda square minus trace of A into lambda plus determinant of A into 0. So trace of A is equal to sum of the diagonal element 1 plus 4 is 5, and determinant of A is equal to 4 minus 10, that is minus 6. So characteristic equation is lambda square minus 5 lambda and minus 6 is equal to 0. That means lambda minus 6 into lambda plus 1 equal to 0. That means lambda is equal to 6 and lambda is equal to minus 1. So 6 and minus 1 are the eigenvalues of A. Next question is, matrix A is given and we have to find the characteristic equation of this matrix. Again, the characteristic equation is lambda square minus trace of A lambda and minus plus determinant of A is equal to 0. Lambda square, trace is 3 minus 4 is minus 1. So minus 1 into lambda, and determinant is minus 12 plus 10. That means lambda square plus lambda minus 2 equal to 0. So this is the characteristic polynomial for this matrix A. Next question is, the characteristic equation of matrix 2 by 2 matrix is given lambda square minus 9 lambda minus 1 is equal to 0 is given. We have to find expression of A inverse. So we are going to use the Cayley-Hamilton theorem. So Cayley-Hamilton theorem states that every matrix satisfies its characteristic polynomial. So we replace lambda by A, so that we get A square minus 9A minus I. Because this is matrix, we can't write minus 1 here. We have to write a matrix which is identity matrix. So by Cayley-Hamilton theorem, we have this one. We have to find the expression for A inverse, as determinant is not equal to 0. Therefore, we can find A inverse. So we can multiply by A inverse. So multiply by A inverse, we get A inverse A square minus 9 into A inverse A minus I into A inverse is equal to 0. So expression for A inverse is equal to minus 1 into 2, that is A minus 9i. So this is the expression for A inverse. Again, for this matrix we have to find A inverse. By Cayley-Hamilton theorem, we have a square minus 2a minus I is equal to 0. Multiply by A inverse, we get A inverse a square minus 2a inverse a minus A inverse is equal to 0. That means A inverse is equal to A minus 2i. Don't write A inverse is equal to A minus 2. Next, if A is diagonalizable, what is value of P inverse A into P? So, definition of diagonalizable matrix is A is diagonalizable if and only if P inverse there exists matrix invertible matrix P, so that P inverse A P is equal to D, where D is nothing but a diagonal matrix whose diagonal elements are eigenvalues of A. So I am considering this matrix A is 3 by 3, therefore I am writing this D as this one, diagonal matrix whose diagonal elements are lambda 1, lambda 2, lambda 3. Last question is A is diagonalizable and A is given, we have to find diagonal matrix. That is, we have to find D such that P inverse A into P is equal to D. So we have to find the eigenvalues of A. So for that for this 2 by 2 matrix we have P inverse A P is equal to D, which is equal to, for 2 by 2 matrix we have D is equal to lambda 1 0 0 lambda 2. For that we have to find eigenvalues of A. So for that we have to find characteristic equation lambda square minus trace of A lambda minus plus determinant of A is equal to 0. So lambda square minus 5 lambda plus minus 6 is equal to 0. Determinant is 6, minus 6 here. So this is the characteristic equation and values of lambda are 6 and minus 1 are the eigenvalues. So this matrix D is equal to 6 0 0 minus 1, or you can write D as minus 1 0 0 and 6.